Okay, problem 1045, it says solve for x and r, where, x is a real number, and this is the equation over here. Again, certainly we went through it, and certainly I talked through it, got a solution to it that was easy, and then I got a solution that wasn't so easy using Newton's method. But again, I had a visual understanding of the problem before I attempted it, and the visual understanding really led me quite quickly to the number 2, and it led me quite quickly to thinking that it's close to minus 3, but not minus 3 certainly. And we went through Newton's method to get the other solution. I'm always curious that, if what I'm doing is what other people would be doing. And sometimes I look at this saying, what method do you prefer? And certainly there's a lot of different methods to do a problem. This is the method I would approach the problem. Certainly what I'm going to do is going to go to openai now and ask it to solve the same problem, see what it does. All right. So all I'm going to do over here is just do a copy of the actual code. I'm going to go to the internet. I'm going to type in openai. And I'm going to copy. I did copy already. I'm going to paste that in and just hit return and see what happens. Again, it's going to go through a process of letting me know that it's working on the problem, but it'll certainly share what it does. All right, I'm kind of curious what it's going to do over here. And again, it's very similar. What are the roots of it? And got the f of x down. And, they go through some analysis. It's not so bad to do that. And they go through some trial and error. Again, this seems like a lot of work over here, but they're doing it. And they say, so there's exactly one root between 2 and 3, but since we found a 2, that's the root. And then it says check for negative roots over here. And it says a root lies between minus 3 and minus 2, and certainly that seems reasonable to me. It wants to approximate it, and I'm not really quite clear how it's doing it, but it's saying it's close to the minus 3, as I said. Now again, their approximation is not as good as mine. Let me go back to that. All right. And my approximation, if you recall, let's go back to that, was this number over here. Now granted, I'm not saying their approximation is bad, but it's not as good as mine. All right, so what is mine over here? Certainly, they got the first 2 digits right. The next one, the 9's incorrect, by the way, because actually it's an 8 there, and even if you rounded it wouldn't be a 9. But they did a good job, and the way they did that, it looked like they're bisecting to get this. And that's not a bad way of doing it. I'm going to say Newton's method is a far more efficient way of doing it. And I would encourage using Newton's method or some other numerical technique, including using Sage, where Sage could actually find a root using another approximate method, which is probably better than Newton's method. Thank you.